Welcome to How to Become a Production SQL Database Administrator. My name is Raphael. In the next several series of videos, we're going to look into the concept of indexes. In the previous video, we looked at the Redgate application and we populated a database and a table with 50 million rows so we can understand indexes a little better. So now we're going to be concentrating on specifically what indexes are. So the next series of videos is going to ask the question, what is an index? What is the purpose of an index? The types of indexes, and creating an indexes both using the T-SQL and the GUI interface. And this will be the start of the first few series, and then I'll continue with this next. So let's look at what is an index. So let me go over here and begin that process. So let me answer this question. So what is an index? An index can be best described as a pointer to a data in a table. And an index in a database is very similar to an index in the back of a book or a phone book. And I'll illustrate that in 1 second. And indexes actually are created on either on a table or in a view. So when you create a view from a table, from a base table, you can also create indexes on those. So what is the purpose of creating indexes? Well, the primary purpose of an index is to retrieve data from a table efficiently and fast. The key word being fast. That's the whole idea of purpose of an index, is to retrieve the data from a table when it has large amounts of data fast. The types of indexes that are in the SQL world are as follows. There's clustered indexes, there's non-clustered indexes, there's composite indexes. Let me continue here. And there are other indexes that we will not discuss, but they're covering indexes, full text, filtered indexes, column-based indexes, spatial indexes, and XML indexes. So the most common ones that we're using, or at least I use, are as follows: clustered index, non-clustered index, and composite index. In the next couple of videos, I'm going to be dedicating to these three, while I certainly encourage you to learn more about these, but just notice that they are there. Now here you'll hear it says other less used indexes, but that all depends on your company. Some companies may use this more often than the other, or some may use that, but it all depends on the company. And then I'm going to give you the T-SQL, example of T-SQL of how to create the clustered index and what are the benefits of having a clustered index. So let's go to that now. So remember, the primary purpose of an index is to retrieve data fast. And we'll be going into the pros and cons of that in later videos. So let me now jump to SQL. And here we begin. And again, all this syntax will be provided for the full course. So here I'm going to give you an example. Let me just rearrange that. Here I'm going to give you an example of creating what's called a clustered index using T-SQL. Now, what is a clustered index? Well, let me go back to here and just explain that. So we said there are many types of indexes, and one of them, the more common ones, is what's called a clustered index. Clustered indexes sort the data rows in a table or a view based on their key values as such that it can only be one clustered index per table. And I'll illustrate that in a second and you'll get a better idea there. When a table does not have an index, it is referred to as a heap. So any table or a view that does not have any form of indexes is referred to a heap. And a heap is basically a database or a table that is not sorted in a particular way. When you create a clustered index, it does not require additional space. And I'll be illustrating that point. The reason I say that is because when you create non-clustered indexes, which will be on the next video, it does require space. So remember that when you create a clustered index on a table or a view, it does not require additional space. And then if you do not have a table or a view for any form of index on it, it's referred to as a heap. So some terminology there. So now let's look at this, what is a clustered index, and I'll be giving you that example here using T-SQL. So the first thing I'm going to do actually is, if you go to here, you'll see the SQL2 database, and if I expand that, if I expand the table, click on table and refresh, you'll see that I do not have a table called phone book. So the first thing I'm going to do is use this command to create a table called phone book. The columns that I'm going to use is phone ID, phone book ID, last name, first name, and the phone, which is obviously a creation of the fundamentally of a phone book. So let me use that database and create a table. And there it is. And if I refresh this, you'll see that the table has been created. And there it is. And right now, obviously, it does not have any data. So what I want to do now is insert 1,000 records using the Redgate application that we used. So go to your Redgate application, open it, continue because it's going to be a trial. Again, make sure you select the appropriate server, and mine is 2014. Now let's go refresh. You may not have to refresh it, but if it's local. And let's choose the database, SQL2, and go OK. And obviously, just like previously, it's going to recognize all the database and the tables connecting to it. And it'll just take a second. And there we go. So click on the phone book table that we created. And as you can see, these are the columns. Now, you'll notice here that these are the things that we want to generate. So by default, it does 1,000 records, which is fine if we want to use 1,000 records. But actually, I'm going to use 100. So I'm just going to just delete that. But well, let me just take that out also. Maybe, okay, and there we go. So this is the kind of data we're going to have. Phone ID, last name, first name, and phone number. And I want 100 records. So I'm going to go generate data. And that should just take a split second. And it does, as you can see. So we can now close this. And we can close this. Do you want to save? Go no. And now if I do a select statement and view you'll notice I've got thousands here, but I originally had 1,000, but it doesn't really matter. So right now I'm going to select from that phone book, do a select statement, and there we go. Okay, one thing I want you to notice, which I'm glad it happened, is you'll notice that the Nicole has 2, Holly has 6, 7, 8, and 2, and I don't want these. So what I'm actually going to do is I'm going to drop the table. So if you do get that, let's just drop the table and recreate it. So I'm going to recreate the table, execute, do a select statement, and there it is. So go back to your data, and I'll show you how to correct that. So if you forget to do that, which I did initially, but that's fine. That's how we learn. I did correct it in the previous one, but I wanted you to see it. So if you get it, you'll see how I corrected it. So just go select the appropriate one, select the database, go OK. And what you want to do now is, once you select the table, click on the column and you'll see these numbers here. So just delete these, go backspace on these and get rid of the numbers. There we go. Click on that, do the same. And that's fine. And now we can generate 1,000. Let's just say 1,000 doesn't really matter. And that's fine. And that takes a second. So now if we look at the table using a select statement, you'll notice that the numbers after the last name and first name are gone. So just take a note of that. So one thing I want you to notice now is that we had the 1,000 records here, and it says view the 1,000 records. Notice that the last name is not in any particular order. So if you look at the last name column here, it's not alphabetized. It's not sorted. There's N, then there's C, then there's P, the D, and so on. And if we go all through there, you'll see it's not in any alphabetized particular order. Now what we're going to do is just take a note of the last name. It's not in a particular order. So now what I'm going to do is it does not at this point have what's called a clustered index or any indexes. This is what's called a heap. There is no organization in terms of last name, first name, or the phone. And as such, it's called a heap. So what I'm going to do is I'm going to insert a record into the phone book table, and notice that the row is inserted after the 1,000th row, as there is no index and the last name is in no particular order. So I'm going to use an insert statement, and notice that I'm inserting the last name Abba. So obviously, if it was sorted, it should become in the first position. But if I take that and insert it and go execute, one row affected. Now if I look at the phone book and I scroll all the way down, you'll see it does not appear in the top as it should. As what happened actually is being inserted wherever the next place it was, and in this case 1001th place. Because there is no clustered index or any indexes, anytime you insert data, it just randomly inserts whatever there is space after the fact. In this case, after the 1000th row. So I can repeat that now. So I'm going to repeat it using Turner. And I'm going to insert another record. Look at the table again. And you'll notice that the order of the last name has not been altered because there is no clustered index. And as I said, that every time you insert a record, it will just go in the next available slot, in this case right here. So the first one was ABBA, second one was Turner. So now what I'm going to do is demonstrate the purpose of a clustered index. I'm going to create a clustered index on the table called phone book and on the column called last name, so that the last name is alphabetized, meaning it's sorted by the clustered index that we are just going to create. So when you create a clustered index, the syntax is as follows: create clustered index followed by the index name. Now if you notice my notes here, the index name is with a prefix. IDX is just name and convention, underscore, followed by the table name, underscore, followed by the column name. This just gives a clarity as to what was clustered, or what was created a clustered on. On, phone book, and then last name. So the table name and the column name. So now if I highlight this and execute it, it's successful. If I go over here, first of all, let's just refresh the tables so we can see the phone book table. If I expand the phone book, expand the index, you'll see that the index that I just created through the GUI has been, through the T-SQL has been created. And if I double click that, if I double click that, you'll notice that the index property comes up, and you'll see it's exactly the same thing. This is how you can do it through a GUI, and I'll show you that later. So there's the table name, there's the index name that we called it, the type of index cluster, and so on. So now that I've created an index, a clustered index on last name on that table, what it should do is sort the last name column by alphabetized. So if I look at the records now, view the 1000 records, this time notice that the last is in order by the last name. So if I execute this, you'll notice here, as I just scroll down here, that indeed the last name has been alphabetized. A's, B's, C's, and so on. But one thing you'll also notice is that this is a phone book example. And as such, you can only have one clustered index on a particular table when you're doing a clustered. There's no way for me to have another index on a last name and first name, as they will not be sorted properly. So you can remember, you can only have one clustered index per table. And now with the clustered index in place, if we insert a record, it will automatically be inserted in the sorted area. So now look, if I'm going to insert Brigham, previously prior to the clustered index, if I inserted a record, it would go all the way down. But now since it's got a clustered index, and if I execute this with a select statement or an insert statement, and now I use the select statement, you'll notice that it is indeed being sorted. And now it's not at the end, but where it should be, and that is Brigham, which is Brig, B-R-I-G, right there. As you can see, it's all alphabetized. So that's the great advantage of having a clustered index and the explanation of a clustered index on a table. It primarily sorts the data based on the column you index to, and it does not take up space. All it does is rearrange it. So the best analogy, obviously, when we're discussing cluster index is that of a phone book. So obviously a phone book, as you notice here, for example, take this example here, this phone book here, or actually let's look at this example right here. You can see the A's here and the B's and the C's. If I were to rearrange this by last name or first name, the book itself will not get any thicker. All I did was rearrange the data within the yellow pages if I'm using a cluster index. So that's an example of a cluster index where if I rearrange the data within the phone book, either with the first name or the last name or the phone book, then it doesn't necessarily increase in size. Its size is going to remain the same. And that's the difference between a non-clustered index, where a non-clustered index actually takes a space. And that is an example of a book index. When you have a book, you have several pages at the end of the book, and those are additional pages or additional disk space in terms of SQL. So that's how to understand what a cluster index is. It basically just sorts the data. So I think I've given enough illustration of what a clustered index is and given an example of what it does in terms of sorting the data and a couple of rules. And rules 1 is that you can only have one clustered index per table. The rule 2 is that it does not take up physical space as it just reorganizes the data in alphabetized or whatever column you select. And those are the few things. So now you can drop it if you wish, but I think I'm going to leave it there and pick it up with next. So next video, obviously, I'm going to be discussing what a non-clustered index is and the benefits of that. So I'll leave it here, and my name is Raphael, and this is how to become a production SQL database administrator. See you in the next video.